So as stated, we are going to be able to still use the elimination process, especially when the equations are in standard form. This is when the elimination method is the most efficient. But sometimes we don't have that, you know what, they already have opposite x terms or y terms. We can't just get away with renaming one of them to create those opposite x's or y's. Sometimes we have to rename both of them so that when we add them together, the x's or y's will eliminate. Like I said, there's an infinite number of ways to do this because we really just have to create opposites, whether it's in the x's or the y's. So you can multiply by as small a numbers as you want or as big a numbers as you want to make this happen. The smartest thing to do is be efficient, right? Okay, so let's hear some of what you think would be an efficient way to go about this first one where we have negative 5x plus 2y equals 32 and 2x plus 3y equals 10. That's one possibility. Which one you came up with, Cameron? I asked you to be thinking about it. And looking out the window is not doing that, I don't think. I don't think it's accomplishing it. Eddie?
For the top one, you can multiply by -3 and then the bottom one, you multiply by 2. So the y's will cancel out, so you have -6y and 6y.
Okay, so I'm just going to, not that you have to write this, maybe you've already filled something in, but I'm just going to write what he just said so that you can follow it. He says if you multiply the top one by -3, his goal was there to create a -6y. That was, because you have to kind of think about both of them together. And then he said, but then I would multiply the second equation by 2, because then that would create a positive 6y, and I would have opposites when I add them together. So there's one possibility. What's another possibility? Macy?
Multiply x by top one by 2.
Okay.
Bottom one by 5.
By 2 and by 5, and what are we trying to create? We're trying to create opposite x's or opposite y's this time? X's. So I'm looking at it and I say 2 times negative 5x would be negative 10x, and 5 times 2x would be positive 10x. That would create opposite x terms for us. So there's another possibility. Others that you came up with. Okay, these are the two most efficient ways. So, if you didn't come up with any others, that's good, because these would be, one of these ways would be the most efficient way to do it. We could go crazy and say, you know what, I want to make that negative 5x into a negative 20x. And I want to make that positive 2x into a positive 20x. So then we could multiply by factors that would create that. We could just, work with different numbers, but no reason to necessarily. So let's use Macy's here. Okay, let's use Macy's. The one I have up there right now. So our goal will be, we're going to take that first equation and we're going to multiply it by positive 2 and the second equation we're going to multiply by 5. So first, make sure you can clearly tell them where you're renaming them and so that we get some good new names for them. So the first one's new name will be negative 10x plus 4y equals 64. The second equation's new name will be 10x plus 15y equals 50. Did I make any mistakes? Do you agree with me? Catch me if I did, now would be a good time to do that. So again, remember I cautioned you before, when you're using the elimination method, where do we typically forget to do the multiplying? On the what? On the other side of the constant. Oftentimes we forget to multiply that. We remember to do the side that has the variables, because that's what we're trying to create, our opposite variables, and then we forget about that other side. And then it doesn't go so well from there. So let's line up our new named equations, ready to do an addition problem with them. And if after you've set up this addition problem, you can see that you need to really look and make sure that you have those opposite x's or those opposite y's before you go ahead and just cross them out and say, well, I had some 10s anyway. So we have a negative 10, a positive 10. Those do cancel each other out. We can go to solving it from here. So we have 19y equals 114. Well, what multiple of 9 ends in a 4? 9, 18. Multiple, so 54 ends in, so a multiple of 9, I said, that ends in 4. So a multiple of 9, 54, which is how many times? 6? Okay, let's see. Do you think 6 times 19 is 114? In other words, I'm trying to get you to work without that calculator. And so we could just take that 19 rounded up to 20, and we could take that 114 and round it up to 120 and say, looks like it would be about 6. So is 6 times, so what we really have to do next, of course, is divide both sides by that 19. And if I take 6, 19s and multiply that, just do the reverse, do I get 114? We actually do. So we have y equals 6. Okay, and now we need to go and solve for our x. Well, when we solve for our x, we have like 4 options now. We have the original first equation's name, its new name. We have the second equation's original name, its new name. You can pick whichever one you want. So go pick one of those equations and solve for x. Plug your y value in and get your x value. Which one do you like? I get -4 for x. What you get? Anybody use the same equation I did? I used the second equation's first name because it had smaller numbers in it, no negatives. I thought, you know what, I like that one. Anybody else use that one? Okay. Let's hear what other ones got used then. What'd you use, Colin? That one, even though you didn't put your hand up, huh? Kayla, which one did you use? That one, even though you didn't put your hand up. Elizabeth, which one did you use?
10x plus 15y equals 50.
So you used our new name for the first equation, okay? Riley, which one did you use?
The first one.
The first one, so as a -5x plus 2y equals 32. Okay? So the only one that so far anyone hasn't said they've used is the first equation's new name. Anybody use that one? Haley, you did? Okay. So did we all get the same answer though? Did we all get that x equals -4? Anybody have a different answer that you want to share with us in case we need to be challenged? Okay, so we're going to say the ordered pair answer is what then? -4, 6. Good news, I'm letting you know to check problems today. Okay? But maybe only 6. Okay, anybody have any questions? Okay, let's go to that first one on the back side. And we have, again, there's an infinite number of possibilities. Come up with something you think would be a good choice for this one. 2x plus 5y equals 26, 3x plus 4y equals 25. No way we can add them together as they are. No way we can just rename one of them unless we want to work with a fraction. We could if we want to work with a fraction. So we're going to rename both of them. What should we rename? Anybody have a suggestion? Or you just want me to let you do this and you can see if you get the right answer? Chase?
Top one by 3 and bottom one by -2.
Okay, so you wanna multiply the top one by 3, because you're trying to create what? Opposite x's or opposite y's?
Opposite x.
Opposite x's. So you're trying to create 6x with that one, and then you wanna multiply the bottom one by what?
-2.
-2, because that will give us a negative 6x, okay? It's a possibility. What's another possibility? Macy?
top one by 4, bottom one by -5.
Yeah, you know what? That's the one I want to do. Just for the fun of it, because I want to get rid of the y's first this time. So I'm going to multiply the top one by 4 because that would create a 20y. And if we multiply the bottom one by -5, we would get a negative 20y. This is huge. You're going to make a good decision right here so that when you really do rename them, you will eliminate a variable. So we're going to take the first equation and we're going to multiply it by 4. If you've already started doing a different one, go ahead and finish what you did. It's okay. You should all get the same answers in the end. And we're going to multiply the second one by -5. Okay, go ahead and get those renamed. And those of you that are doing the same one I am, these are the new names I got. You need to challenge me on them. I really seriously encourage you to just stop and take time to double check your work, because you know there's nothing more frustrating than when you get all that work done and you get down there and you're like, oh my, this is not looking good. Where did I go wrong? And then you're going to go back and find it when you could have found it possibly right away in the beginning. So anybody find a mistake in mine? Do you agree with me? Okay, so we're ready to add them together. Go ahead and get this one solved for x. Let me do it for you, so you can see if you agree with me when you're done. I get x equals 3. And if you're done solving for your first variable, go ahead and get your second variable solved for. You choose which equation you're going to use, because again, you have like 4 choices. So which one do you want to substitute your x value into? This is typically the step that takes the most amount of work. I feel like it should be the one that does, but it does. And when you're done, you can see if you agree with me. So whether you solve for y first or you solve for x first, we all should get the same ordered pair solution in the end, which should be ordered pair 3, 4. Agree? Disagree? Agree? Okay. So again, the only thing really different today is you have to rename both equations to create those opposite x terms. Okay, let's turn in our books to page 346, because you are going to do some application problems today. application problems mean you have to set up your own system of equations after describing what your variables are going to represent. Use the elimination method to solve, and write a sentence answer in the end. So we have the middle of the page, check it out, number 4, what if? Okay, who wants to read that for us? Volunteer to read. Volunteer to read. Stop working and let's read. Thank you, Austin.
Sally spent $14.85 to buy 13 flowers. She bought lilies, which cost $1.25 each, and tulips, which cost 90 cents each. How many of each flower did Sally buy?
Okay, thank you, Austin. So first thing we got to decide is what are the unknowns? What are our variables going to represent? Typically, like I've said, you just look at the question they asked or told you to find. So what do we need to find? Lilies and tulips. What about lilies and tulips? The color of them, the number, okay. Price of them. What is it going to be? So over here, let's put X is what? What do you want them to be? The number of lilies or the number of tulips? Doesn't matter. Number of lilies. And that makes then Y the number of tulips, right? Okay. Yesterday, the other classes got a little bit extra practice with application problems again, when you couldn't do it. But so again, we have to, every time we do these application problems, we have to describe our variables like this. And then we set up a system of equations using them with the information that we were given. So what's one of the equations we could set up for this one? Got one, Eddie?
1.25x
Okay, 1.25x plus 0.90y, and then I lost you. Okay, equals 14.85. So we gotta see if this makes sense. If we're taking 1.25 times the number of lilies, that's telling me that we're gonna find how much money was spent altogether just buying lilies. So they were $1.25 each lily. This, the 0.90y tells me that, you know what, we have y is the number of tulips bought, and at 90 cents each, that should give me, after I multiply, it should give me how much money was spent on tulips. Add those two together, altogether, she apparently spent $14.85. Okay, so good equation. What could the other one be? Got it, Chase?
X plus Y equals 13.
X plus y equals 13. So in other words, the number of lilies plus the number of tulips should give us the total number of flowers. And number 13. Okay, those are good equations. Okay, now we have to decide, they're both in standard form, so the elimination method is the handy method for this one. We're going to look at the equations and decide, do we really have to rename both of them, do you think? Could we get away with just renaming one of them in this situation? Okay, so we could take that second equation, couldn't we, and create either opposite x's or opposite y's. Now I'm also going to make another suggestion, though, that we rename that first one, getting rid of those decimals, before we do rename that second one. Because you know what? It's so much nicer to work with whole numbers than it is those decimals. So we really could, by moving the decimal points in this one, we really could rename it. So we would, every one would move over 2 places, because you're going to do the same thing to every one. That one could get renamed 125x plus 90y equals 1,485. Now you might think, I'd rather work with the decimals than that big of a number. Well, feel free, you can. What should we then? Do you want to create opposite x's or opposite y's? Which one? Opposite y's. Okay, it's a little bit smaller number, so we'd multiply that second equation by a negative 90 then, wouldn't we? So we would equation and we would multiply both sides by negative 90. We're renaming the second, so we renamed the first equation to get rid of the decimals. We're renaming the second equation by multiplying by negative 90 to get the y's to become opposites. So we have negative 90x plus negative 90y equals negative, well, 10 times 90 is, 10 times 90 is 900. 3 times 90 is 270. 270 plus 900 is 1,170. Look at there, we did it without the calculator. Okay. So we have renamed the second equation. Now we can take it over and we can add it to our first equation that got renamed. So we have negative 90x plus negative 90y equal to a negative 1,170. We did create opposites. We have a 90 and a negative 90, so we can move on. How many x's do we have when we add those together? It's really 125, take away 90. What is that? What is that? 35. This is really 1,485, take away 1,170. Well, 70 from 85, first of all, is 15, and 100 from 400 is 300. So we have 315. Okay, so next we're going to divide both sides by 35. And we're going to try to do this without a calculator because I'm pretty sure we can, huh? 35 times 10 is what? 350. How far away is 315 from 350? 35. So what do you, how many times are you supposed to go in there? No, we went 10, we went up to 350, so it'd be 9. We have to take 1 away. So this is x equals 9, okay? So we have that, but of course we're going to answer in a sentence answer in the end anyway, so we'll just circle that so we know what we got for x. And now go use one of the equations to get your y. Well, the smartest one to use would be which one? Second one in the beginning, right? X plus y equals 13. Don't make this any harder than you need to. Okay, now we'll just do a mental math check. Well, 9 of one, 4 of another, they do add up to 13 flowers, right? Okay, the harder one to do is the money part, isn't it? You have to actually do a mental math check of that. So what we can do is kind of like an estimating mental math check. If we take that 9 and round it to a 10, what's 10 times $1.25? What's 10 times $1.25? $12.50. Okay, we're going to round that 90 cents up to $1. What's $1 times 4? $4. So we got $14.50 plus $4. That's what? $14.50 plus $4 is. Don't worry about it's not coming out exactly. Remember, we're rounding. $18.50. Doesn't have to come out to exactly, you know, what we're, because we rounded up. We're just making sure it seems somewhat reasonable. So once we decide it seems somewhat reasonable, we're ready to write our sentence answer. What's her name again? Sally? Okay. Sally bought. Did you have a question, Avery? Oh, okay. Sally bought. Thought maybe I made a mistake somewhere and you just wanted to correct me, and that's a good thing. So, what did she buy? 9 lilies. The word and, A-N-D, and 4 tulips. The only thing I let you abbreviate basically is I let you use the number for the numerical answer parts we got. Capital letter at the beginning, punctuation at the end, no abbreviations in between. Sally bought 9 lilies and 4 tulips. That's how we will end our application process always with a sentence answer. Okay, questions? Okay, then I believe you have 10 problems for homework, so I'll let you get started.